in a dry, windswept region of northern Namibia, far from any industrial mine or geological survey. A discovery unfolded that would shock experienced gemologists and puzzle even the most seasoned field prospectors. It began not with satellite imagery, not with advanced seismic equipment, but with the strange behavior of termites. Yes, termites digging quietly beneath a cracked acacia tree. The story starts with a small team of artisanal miners, working under harsh sun and with outdated tools, near an area previously dismissed as non-productive terrain. The land showed no surface evidence of kimberlite pipes, the volcanic rock formations traditionally associated with diamond-bearing deposits. There were no rivers nearby known for alluvial diamonds, but something about the soil kept attracting their attention. It wasn't the sparkle of quartz or the presence of garnet. It was termites. Thousands of them. The team observed that one particular termite mound, larger and denser than the rest, had begun to collapse in on itself. But what was strange was the color of the soil they were pushing up. Termite colonies are known to bring up material from meters below the surface to build their structures. This one was pushing up pale gray, slightly magnetic gravel with flecks of olivine and peridot. To anyone trained in basic geology, those were indicator minerals, clues that something deeper lay hidden. Out of curiosity, the team decided to break into the mound. What they found sent a jolt through the group. Embedded within the hardened soil matrix were tiny octahedral stones, clear, glassy, and with the telltale greasy luster of raw diamonds. A quick scratch test on a mirror confirmed their suspicions. They had stumbled onto something big. But how? What followed was a rapid escalation in fieldwork. They marked GPS coordinates, collected soil samples, and began digging shallow trenches around the termite mound. The more they dug, the more they found. At first, it was a handful of stones, then dozens, then hundreds. Some weighed under a carat, others nearly 2. The deeper they went, the clearer it became. This wasn't an isolated pocket. It was a vein unmapped, untapped, and stretching farther than their rudimentary tools could follow. The term unmapped is key here. Most diamond veins are identified through extensive geological surveying, but this one had remained hidden beneath a layer of weathered basalt, missed entirely by previous aerial scans. The termites, through their instinctive tunneling, had reached what scientists later determined was a feeder branch of a much larger kimberlite intrusion. Within weeks, word of the discovery began to spread. Geologists from Windhoek, then from Cape Town, and eventually from overseas, flew in to verify the claim. What they confirmed stunned even the professionals. The vein was real, and preliminary sampling indicated that it had an unusually high diamond content per cubic meter. One geologist from the University of Pretoria estimated that the small exposed section alone could yield up to $7 million worth of raw stones, if extracted properly. And yet, what captured the world's attention wasn't just the value of the diamonds. It was the bizarre origin of the discovery. How could such a massive deposit have remained hidden in plain sight for decades? And how had 6,000 termites unknowingly become the best geologists in the region? What followed next wasn't a rush of bulldozers or corporate claims. It was a scramble for understanding. The initial artisanal team was overwhelmed. Their pickaxes and metal pans were no match for the geological significance of what lay beneath their boots. But as they continued to collect specimens and plot their trenches with rudimentary GPS units, something peculiar began to emerge from the data. The diamonds were not just random inclusions in sediment, they were aligned, almost as if following the path of a narrow geological fracture. This pattern hinted at something deeper. Not just a pipe, but a feeder system, an arm of a larger kimberlite body feeding upward through ancient fractures in the crust. And because the region had never been formally surveyed due to its remoteness and lack of surface expression, the intrusion had sat dormant, quietly hidden below the oxidized basalt cap for centuries. The only thing that had interacted with it were termites. Geologists arriving on site brought portable X-ray fluorescence (XRF) scanners, magnetometers, and core sampling drills. But even their advanced equipment confirmed what the termite mound had already revealed: a consistent presence of pyrope garnet, ilmenite, chromite, and magnesium-rich olivine, the signature trace minerals left in the wake of diamond transport. The color gradients of the soil core match known feeder limb behavior, where molten kimberlite had once ascended, explosively but cooled before breaking the surface. What made this even more extraordinary was the uniformity of diamond crystal shapes. The majority were octahedral, some with trigon marks sharp, triangular etchings caused by natural corrosion in mantle fluids, while others exhibited flawless terminations and zero signs of transport erosion. That meant they hadn't traveled far. These weren't alluvial stones washed down rivers. They had sat largely undisturbed, right where nature had placed them. And yet, it was not machinery nor geology that found them first. It was biological behavior. A growing group of mineral ecologists began studying termite movement patterns, realizing that mound placement in certain geologic settings could inadvertently flag subsurface anomalies. In effect, the termites had mapped what decades of satellite surveys had missed, but as news broke, danger followed. The area, once silent, began to echo with the sound of quad bikes and boots. Rival prospectors, eager to strike fortune, descended without permits or plans. Some carried outdated Geiger counters, hoping to pick up trace mineral spikes. Others simply followed termite mounds blindly, hoping to replicate the miracle. Local authorities had to intervene. Tensions flared as claims were staked, and a temporary ban on extraction was issued until the site could be formally assessed and secured. Meanwhile, the original discovery team was offered a conditional contract by a mid-sized exploration firm based in Canada. The deal: provide detailed trench maps, coordinate logs, and 25 kilograms of verified sample in exchange for a stake in any licensed future excavation. For miners who had lived day to day for survival, the offer was life-changing. But they didn't agree right away. Some of them, deeply superstitious, believed the termites were assigned guardians rather than guides. They feared what might follow if the land was violated too quickly. A month later, after a series of preliminary drill tests confirmed the extent of the deposit, a quiet excavation began, regulated, documented, and protected. No explosives were used. The work was surgical. Soil was removed by hand, then sifted layer by layer. In just the first 3 meters, the team extracted over 160 carats of rough diamonds, some large enough to require classification by industrial sorting. One stone in particular, pale yellow with near-flawless structure, was estimated to be worth more than $40,000 on its own. And that was only the beginning. The termite mound, now preserved under a climate-controlled shelter, had become an international symbol. Photos of it appeared in scientific journals and on gemology forums. Students and researchers around the world began asking the same question: how many other deposits like this have we overlooked? And if termites could find one, what else might the natural world be trying to show us if we just learn how to listen? The growing media attention turned the termite mound into a strange sort of monument, half relic, half revelation. Documentarians flew in from Europe and North America. A drone shot of the site made its way into a viral YouTube video where a red circle highlighted the mound as if it were a UFO landing site. But the real mystery was just beneath the surface dash, literally dot, as the team continued their controlled excavation. They noticed that the concentration of diamonds wasn't uniform. The cluster appeared to radiate in a branching pattern, almost like veins, but not like blood vessels. More like root systems or even fracture maps seen in cooled volcanic glass. The discovery sparked a theory. What if the diamonds had traveled upward through a network of microfractures from a deeper, undiscovered kimberlite pipe miles below? It would explain not only the precision of the cluster, but why the larger geologic scans had missed it entirely. Unlike standard pipes, which burst to the surface and scatter indicators, this one may have leaked upwards slowly over millions of years, just enough to leave a trail. The termites could inadvertently trace dot. It was around this time that a professor of geobiological interaction from the University of Colorado published a short paper with a provocative title, Termite Geomapping, Biological Pathfinders for Subsurface Kimberlite. The theory, once fringe, was now gaining momentum in scientific circles. According to the paper, termite mounds in geologically stable regions showed a statistically significant increase in trace kimberlite indicator minerals compared to random sampling zones just meters away. In other words, termite architecture might not be random at all. It might be driven by mineral gradients deep below. For the diamond hunters, this changed everything. They began mapping termite mounds across a 10-kilometer grid, collecting soil samples at varying depths and documenting termite foraging behavior. What they found startled even the skeptics. In 4 of the 7 mound clusters, similar trace minerals were present, some with tiny garnet fragments, others with magnetic chromite. This new method, now dubbed biogenic prospecting, began to draw attention from junior mining companies desperate for an edge in the saturated exploration market. Suddenly, the smallest insect colonies on Earth were being treated like natural geologists capable of guiding humans to multi-million-dollar finds. But the field wasn't without its controversies. Environmentalists raised alarm over the sudden interest in termite ecosystems. Fears mounted that widespread mound destruction in search of gems could collapse local biodiversity. In Namibia, termite mounds provide crucial aeration to soil, enhance vegetation growth, and even shelter other insect and reptile species. The government, balancing ecological preservation and economic opportunity, issued a moratorium. Any future excavation involving biological indicators would require environmental review. Yet even with new regulations, the fever had begun. Prospectors, now equipped with handheld spectrometers and soil charts, began to quietly expand their search beyond the original site. One cluster, located near an abandoned cattle post, showed similar mineral behavior. Another, deeper in the savanna, exhibited olivine content nearly twice that of the original mound. The veins, it appeared, were not isolated. They were part of a larger lattice, possibly stretching dozens of kilometers. And with every stone unearthed, a larger question loomed: if diamonds could form a hidden network beneath the African crust, waiting only for termites to reveal them. How many fortunes had been missed by eyes looking too high and never low enough to notice the insects right beneath their feet? As geologists returned to the site for a final core analysis, one of the original prospectors, his hands still calloused, his shirt sun-bleached, stood quietly at the edge of the trench. In his palm rested a single octahedral diamond, no larger than a coffee bean. He didn't need a lab to know its worth. He only needed to remember how the ground had whispered first, not with machines or maps, but with the soft churn of 6,000 silent workers doing what they'd always done, building something, and revealing everything. As deeper boreholes were drilled, the subsurface profile became clearer and stranger. Instead of a single solid kimberlite pipe, the team began mapping a crisscross network of narrow fissures, filled with diamondiferous material. These were not typical pipes. They resembled seepage channels, thin and twisted, almost like veins that had leaked through fault lines over geological time. And yet, the diamond yield per cubic meter remained surprisingly high. No known model could fully explain the distribution pattern. An unexpected finding came from one of the geologists who had stayed behind to monitor magnetic anomalies. He noted faint but persistent spikes in the soil's magnetic field, forming a rough spiral centered not on the original mound, but on a termite cluster nearly 300 meters west. Intrigued, the team redirected their trenching. What they unearthed sent a chill through the camp. There, beneath the soil and roots, was a cache of rough stones larger and purer than any they had found so far. Dozens of them, many with natural clarity levels that rivaled cut diamonds. It was as if the earth had carefully hoarded them away, placed delicately along a single fissure, just within reach, yet hidden from all human detection until now. The camp went silent as each stone was lifted and cleaned under the harsh sun. Cameras rolled, drones hovered, and in that moment, the scale of the find was no longer measured in carats, but in astonishment. This was no longer just a geological story. It was a rewriting of exploration itself, guided not by fortune, but by biology, patience, and sheer observation. Shortly after the discovery, a South African tech startup specializing in AI-driven mineral prediction offered to fund a broader survey. They introduced drone-based infrared mapping, hyperspectral analysis of termite mound alignments, and predictive modeling based on known trace mineral concentrations. The goal: to replicate the Namibian anomaly elsewhere across the continent. Within 6 months, their algorithms identified 13 high-probability zones, from Angola to Botswana. In 3 of them, field validation confirmed elevated concentrations of diamond indicator minerals, again, directly beneath termite mounds. It was becoming undeniable. A new era of biogeological mapping had begun. But for the original team, something deeper stirred. With each unearthed stone came not just value, but a question. How long had these riches lain in silence? How many decades or centuries had termites wandered this terrain, carrying up slivers of buried wealth, ignored by every human eye that passed? They had been invisible, not because they were hidden, but because no one had thought to look that low, or that small. The vein was now officially registered under a cooperative license, with revenues split between local landholders, a scientific research endowment, and the miners who made the find. The site was renamed T6 for the 6,000 termites that had unknowingly redefined an entire methodology of exploration. But not everything was so easily celebrated. As foreign investors arrived and land values surged, tensions grew in nearby communities. Locals feared that their own termite mounds, once ignored, would now become targets for unregulated prospectors. Some erected fences. Others destroyed the mounds themselves, hoping to avoid conflict or exploitation. The Namibian government responded with an emergency resolution. All bioindicator exploration must follow strict permitting, with cultural and ecological protections in place. Yet even these measures couldn't stop the rising tide. Prospecting firms began hiring biologists alongside geologists. Termite foraging patterns were digitized. AI models were trained on mound structure, soil chemistry, and even ant behavior, just in case a second biological species held similar secrets. And so the desert, once a place of heat and hardship, transformed into a silent laboratory where biology, geology, and the remnants of colonial history collided in the dust. But for those who had been there at the beginning, the excitement was tempered by something quieter, a sense of awe, a whisper beneath the surface, and the realization that perhaps the earth was never trying to hide its wealth. It had always been speaking. It just took 6,000 tiny mouths to make us listen. Not long after the T6 site gained international attention, A documentary team was granted temporary access to record what they called the day the desert bled diamonds. But what their cameras captured wasn't dramatic machinery or glittering gems in piles. Instead, they focused on the human faces lined with sweat and disbelief who knelt in the dust, extracting fortune pebble by pebble, some of the original. Miners had now been trained in field spectroscopy. Others took shifts analyzing termite mound locations with newly developed handheld sensors, tuned to detect magnetic anomalies caused by subterranean mineral concentrations. The same men who once dug with shovels and hands were now cross-checking soil data in real time, overlaying it with drone imagery and biological heat maps. They weren't just miners anymore. They were becoming explorers of a new kind. But the most surreal moment came when one of the youngest, miners barely 20, discovered a cache so dense it had to be lifted out in a sheet of fused gravel. When washed, it revealed over 120 rough stones locked together like a mosaic, the largest cluster yet found in a single trench. It was unlike anything even the geologists had imagined. The cluster itself is now on display at the National Museum in Windhoek, enclosed in a custom-built glass vault. It is known simply as the nest. Speculation followed. Why here? Why this pattern? Geophysicists proposed that millions of years ago, a burst of magmatic activity had forced diamond-rich fluids up through a spiderweb of fractures, which hardened just below the surface, deep enough to avoid erosion, shallow enough to be detected by termites digging for moisture during dry seasons. In other words, biology didn't just discover the deposit, it may have depended on it. The implications were staggering. Research institutions began to review past satellite scans, this time overlaying termite colony density with known fault zones and magnetic anomalies. Patterns emerged. What was once dismissed as noise organic interference in data was now recategorized as signal. Other countries took notice: Brazil, Australia, even parts of the southeastern United States. Everywhere termites or similar eusocial insects dug deep for shelter, the same questions surfaced. What have we overlooked? Meanwhile, back at the T6 zone, things took an unexpected turn. While clearing an old trail, a worker stumbled on a decayed tree stump with another collapsed mound beside it. As they peeled away the top layers of crusted soil, they uncovered what appeared to be an ancient tool, a chisel-shaped fragment of forged metal, corroded beyond use. Carbon dating would later place it at over 300 years old. The presence of that tool sparked controversy. Had someone found this place before and failed to recognize its value? Or worse, had the knowledge of the diamond-bearing ground been intentionally buried by colonial powers, seeking to control resources? Local historians reopened archives. Old journals were translated. One partial entry, dated 1724, mentioned shimmering soil and insects revealing stone, but lacked coordinates or detail. For a moment, the narrative shifted from discovery to reclamation. What was framed as a scientific breakthrough began to feel like the closing of a forgotten circle. The diamonds weren't just wealth, they were memory. Evidence that this ground had whispered its story once before, and that history had chosen not to listen. Despite the newfound attention and increasing complexity, the core truth remained unchanged. It all started with one observation: a mound slightly out of place, termites moving in odd lines, a change in soil color so subtle it took a trained eye, or perhaps an intuitive one, to notice. And that's what made the story impossible to forget. It wasn't the equipment or the satellite scans. It wasn't corporate money or academic journals. It was a moment of stillness, of watching the smallest creatures on Earth move with purpose, and asking, why? Because sometimes treasure doesn't hide. It waits quietly, just beneath the surface. Within weeks, the area around T6 transformed from a forgotten patch of semi-arid land into a magnetic epicenter of innovation, scrutiny, and ambition. Helicopters hovered daily, dropping off researchers, news crews, and private investors. Makeshift camps evolved into structured grids. Power lines were extended. An airstrip was leveled. But amid all the movement, one quiet debate echoed louder than all the generators and drills. Should this remain in the hands of the original discoverers? The artisanal miners who had first spotted the mound, who had dug with their hands, who had trusted a hunch about termites, were suddenly surrounded by legal teams, government officials, and multinational firms. Deeds were reviewed, land rights questioned, every contract re-examined. Some feared the narrative would be rewritten, stripping credit from those who lived the story. But the global spotlight made it impossible to erase them. The miners had become symbols of intuition triumphing over technology, of humility outsmarting scale to protect their work. They partnered with a non-profit geological initiative. The goal wasn't just extraction, it was knowledge. Together, they established a field lab beside the main trench. Samples were cataloged not only for gemology, but for paleobotany, magnetometry, and microbial analysis. Every piece of gravel, every termite trail, every fleck of chromite or garnet became part of a broader puzzle, one that spanned millennia. In one study, researchers discovered that the termites had preferentially chosen corridors that avoided certain iron-rich clay bands. This led to a theory that their internal magnetic sense, which helps some species orient underground, was key in leading them toward mineral-rich paths. That insight alone spurred a new field, biogeological mapping. And the diamonds? They kept coming. By the end of month 3, the yield surpassed $8.3 million in rough value. Not all stones were gem-grade, but the frequency was unparalleled. 1 in every 5 samples carried visible crystalline structures. Several reached beyond 5 carats. A rare pinkish-brown octahedron was named the Whisper, a nod to how it had been found resting in a shallow dust layer brought to light by wind and instinct. But not every day brought glory. On the 87th day of excavation, a cave-in occurred during a trench extension. No one was killed, but a lead digger suffered a broken arm, and the incident raised fresh concerns. The pressure to go deeper, faster, had outpaced their safety infrastructure. A 2-day pause was enforced. During that pause, the diggers sat in silence, staring at the mound that had started it all. The mound now fenced off, stabilized, and revered. It was during that silence that something unexpected happened. An elderly woman from a nearby settlement arrived carrying a bundle wrapped in cloth. Inside were polished stones, some quartz, some flint, but one in particular caught the attention of the camp's mineralogist. It had the unmistakable geometry of a diamond crystal, but perfectly smooth, as if water-worn. She claimed her grandfather had found it decades ago while herding goats, far east of T6, but had buried it, believing it to be cursed. That single object reopened everything. If that diamond came from a separate site, miles from the current discovery, it meant that the kimberlite branch network might be vastly more extensive than assumed. Suddenly, the search wasn't just about following termites. It was about listening to forgotten stories, oral legends, even superstitions. Science had gotten them this far, but intuition might take them farther. And so a new phase began, cross-referencing memory with data. Maps were redrawn. Interviews were held with elders. Places where insects swarmed unusually or where the soil shimmered after rain were marked. And slowly, a corridor emerged, faint, irregular, but traceable, like veins beneath skin. At the heart of it all, still, were the termites, digging, building, mapping a fortune that had waited in the silence of the earth. The corridor they uncovered wasn't straight. It curved like a broken lightning bolt across the plateau. sometimes narrowing to barely a meter, then suddenly fanning out into wide beds of ultramafic rock. What made it special wasn't just the pattern, but its behavior. As prospectors sampled along the route, they found something unprecedented. The diamonds were increasing in quality the farther they moved from the original site. Not just quantity, clarity, size, purity. It was as if the earth had been hiding its most valuable truth, not at the core, but at the periphery. Geologists began calling it the termite halo, a pattern of subsurface dispersion revealed, not by machines, but by the tireless, unseen work of thousands of insects. Remote sensing experts from Germany and Canada soon joined, applying hyperspectral imaging to follow the termite logic at scale. Everywhere the imaging matched no mounds, samples proved positive. But where imaging failed, and only local memory existed, the discoveries were even richer. One of the final documented finds happened on a ridge, where an old man had once seen the ground bleeding dust after a rare summer storm. When they excavated it, they found two pipes branching toward the west. One contained the largest diamond recovered to date from the region, an 11.4 carat, near-flawless stone with pale yellow fire, later appraised at nearly $900,000. It was found inside the collapsed tunnel of a termite colony long abandoned. The significance of the discovery reached beyond the minefields. Universities introduced new modules in geology programs titled Biological Prospecting Strategies. Environmental. Scientists studied the symbiosis between termites and deep earth mineral cycles. The Namibian government passed new protections for active mounds, classifying them as dynamic geosensors. And international mining conferences began inviting entomologists to speak alongside geochemists. But for the original team, the ones who knelt in the dirt with mirrors and scratched the first glassy stones, the story always circled back to one thing: respect. Respect for the land, for its creatures, and for the unseen patterns that pulse just beneath the surface. They'd gone from mock treasure hunters to unlikely pioneers, not because of wealth, but because they'd listened differently. Years later, a documentary would close with one of the miners standing beside the old mound, now protected by glass walls and observation decks. He didn't speak of the millions earned or the companies formed. He just smiled and said, "They were here long before us. Maybe they were trying to tell us something all along. And maybe that's the real story. If this kind of discovery fascinates you, you're not alone. We're just beginning to understand the ancient messages hidden beneath our feet and what they might lead to next. Stay curious, stay grounded, and if you like this story, consider joining us for more Deep Earth. Mysteries, forgotten legends, and surprising truths the soil still holds. Your next click could lead to the next revelation.